So very good morning. Today's session we are going to discuss about important problem types which come under the design and analysis of algorithm. In last session, last lecture we completed introduction and notion of an algorithm. So this is focus upon the important problem types. So we discussed what are the different problem solving method available. Before move to the problem solving methods, we must know what are the problems are available. So that's come under the important problem types. So here the find it. So these are the important problem types listed here: sorting, searching, string processing, under that text string, bit string, Jenny sequences, and graph problems, combinatorial problem, geometrical problem, and numerical problems. First we start with sorting. What is called sorting? Sorting is nothing but in shuffled one we are going to arrange in order. That is called sorting. We can arrange the similar items in a single group. That is called sorting. In this example, they arranged the objects in the same color. So this is one kind of sorting. So the sorting is the problem to rearrange the items of a given list in non-decreasing order. Either you may follow ascending order or may follow descending order for sorting. Sorting algorithm is called stable. So when the sorting algorithm is called stable, if it preserves the same ordering, if the unique elements are present in the list. That is, in your input is given, the same number is repeated again. In that, without confusion, it may sort. That kind of sorting is called a stable sorting algorithm. The second is nothing but a in-place sorting. That is, the second notable feature of sorting is algorithm's amount of extra memory the algorithm requires. An algorithm is said to be in place if it does not require extra memory. Okay, so which sorting algorithm does it need extra memory to sorting? That kind of algorithm is called a in-place sorting algorithm. Okay, these stable and in-place sorting algorithm is two different kind of basic sorting methodologies available. Under that we have different examples about sorting. That is merge sort, quick sort, heap sort, bubble sort. So different kind of sorting they already completed in the data structure itself. Then next important problem type is called searching. Okay, so searching is nothing but you're going to find something in a group. That is called searching. Okay, the searching problem deals with finding given value called a search key. Okay, which element you're going to trying to search, that element is called a key element. Okay, in a given set the elements are stored in an array. There are two basic type of searching are available. One is a sequential search, another one is a binary search. So everyone know basically about sequential search in the data structure itself, because sequential search is nothing but you have n number of elements. From the n number of element you have a key element. Already you given with the key element. The key element is x and there are n number of elements present in an array. You are going to search that x in the given list of elements. So how you do this? You start comparing the x value with the first element, second element up to nth element. So this is a sequence. So this is called a sequential search or linear search. Then binary search. Binary search is nothing but here also the same searching method. The search key x is given. Here the method is you divide the given input by 2 by using a mid value. So if you find mid value, that mid value is compared with the x value. If it matches with the mid value, it will return the same. If it is less than the mid value, it will search only in the left side of the list. If it is greater than the mid value, it will search only in the right side of the list. This is binary search. The time complexity of binary search is log n, and time complexity of sequential search or linear search is called as a order of n. Okay. String processing. String processing plays a major role in all areas. A string is a sequence of characters from an alphabet, string of particular interest or text strings which comprise letters, numbers and special characters. So usually how you define a string? String is a collection of characters. That is called a string. How you process the strings? That is, maybe the string may be only alphabets or combination of alphabets and numbers, that is numerical characters. that is called a string, maybe using some special characters and all. So that is comprised letters, numbers and special characters. And bit string is nothing but a zeros and ones, which comprise zeros and ones. And Jenny sequences can be a combination of ACGC, ACGE. String processing, it should be pointed out, however, that string processing algorithm had been important for computer science for a long time in conjunction with computer language and compiling issues. The string process, the best example I will given for string processing is string matching. Okay, if I have two kind of inputs, string 1 and string 2, I am trying to find string 1 content in the string 2. So that if the matches is found, it will return true, otherwise it will return false. This is one of the basic string matching methods solved by using different string matching algorithm are available. There is a naive Bayes algorithm, Kruth-Morris-Pratt algorithm, and it can be solved basic string matching with the brute force technique. Graph problem. So before entering into graph problem, this is not new to you. Those who are completed the data structures already, this is not new to you. Graph can be defined as G is equal to V comma E. That is, G is nothing but a graph that is equal to collection of vertices and edges. Okay, graph can be thought of collection of points called vertices, and some form are connected by line segment is called edges. So here this 1, 2, 3, 4 likewise these numbers represented in circle, these are called nodes, and this link between this line between these vertices is called a link edges. Okay, these are vertices and edges. So collection of the vertices and edges is called a graph. Graph problems can be used for modeling wide variety of applications, including transportation, communication, social and economic networks, project scheduling and games. So all kind of networking we can represent only with help of graphs. Okay, without graph we can't represent any telecommunication network or social media network or aircraft navigation. Everything can be represented in the telecommunication network, everything represented with help of graph problems. So here there are some research areas, computer scientists, economists and social scientists use this graph. The graph can be, the graph have the most wide research areas called graph theory. So these are some basic graph problems. Basic graph problems are shortest path algorithm, whether the shortest path may be a single source shortest path using digit cross or all pair shortest path using Warshall and Floyd algorithms. Then so topological sorting with the directed edges, and traveling salesman. This is mostly used famous problem and DA is a traveling salesman problem, and graph coloring problems also available. Traveling salesman problem is a very interesting problem. The salesman start from the source city and visiting end city, again return to the source city, okay, but less amount of cost or less amount of fuel. That is a traveling salesman problem. Then graph coloring problem, using minimum number of colors you can color the nodes. No two adjacent nodes have the same color, that's a constraint. So these are the important and interesting graph problems. Combinatorial problem. From a more abstract perspective, the traveling salesman problem and graph coloring problem are examples of combinatorial problem. These are the problem that ask explicitly and implicitly to find combinatorial object, such as a permutation, combination or subset that satisfies the certain constraints. A desired combination of object may also be required to some additional property, that is maximum value or minimum cost. So here combinatorial problem, the traveling salesman problem is one of the example of graph problem we already seen, and graph coloring problem also. Here how it come under the traveling salesman is come under the combinatorial problem. Then best example for combinatorial problem is N-Queen's problem also. So here N-Queen, I will take an N-Queen's to explain this combinatorial problem. Then N-Queen's problem looks like this. If I take N is any number, if I will take 4 queens, N is equal to 4, it will be represented in 4x4 chessboard. Okay, so that the condition is there are two constraints, implicit and explicit constraint. Implicit constraint is no two queens is placed in the same column, same row or same diagonal. This is the constraint. So we want to place the queen. If I start place the queen from 1, 1 in the n cross n chessboard, 1, means I will get one solution. If I started with 2, 1, 2, I will get different solution. So I may get n factorial solution for the same problem, but all the solutions are correct. I can't prove this is one is a correct one. So that kind of problem is called a combinatorial problems. Okay, that is implicit constraint. Explicit constraint, one best example is sum of subset problem. Okay, here sum of subset is a set of numbers will be given and sum will be given. If you are adding the numbers, you will get particular sum. Maybe 2 or 3 sets you may get for the sum, but I can't prove this set is correct, that second set is correct, first set is correct. So we can get more solutions, but we can't prove this solution is correct. That kind of problem is called combinatorial problems. Geometric problems. Geometric problems is deal with geometric objects such as points, lines and polygons. The ancient Greek were very much interested in developing procedures for solving variety of geometric problems, including constructing simple geometric shapes, triangles, circles and so on with unmarked ruler and compasses. The best example for this is closest pair and convex hull problem, which we are going to discuss with the divide and conquer method, which will be solved by using divide and conquer and brute force method. Brute force method has some time efficiency. Because of that, we are moved for divide and conquer. Okay, what is called closest pair problem? The set of endpoints will be given. From that, you want to find distance from each point, one point to every other points. So among that, you may find minimum path, minimum distance, that is closest pair problem. In closest pair problem, to find a distance, you are going to use Euclidean distance formula. Convex hull problem mostly used in aircraft navigation, so that we may focus upon the particular route. Okay, so that we will discuss in next lecture. Numerical problems, another language, special area of applications are problems that involved mathematical objects of continuous nature. It's solving equations, mainly focus upon the integral and differential equations calculations. We are using this kind of numerical problems. The computing definite integral, evaluating functions, all kind of functions which cannot able to solve by human within a finite amount of time, we go for this numerical, we go for this kind of problem can be implemented with the help of computers. So this is a simple assessment. If you understand this lecture, you may match this arranging the elements in order. Yes, we move for a sorting. N-Queen's problem, that is come under a combinatorial problem. And convex hull. Convex hull is belong to which topic? As geometrical problem, and integral calculus is a mathematical, is a numerical one, so it's come under a numerical problem. Graph coloring is a graph problem, and find a new string in the existing one, yes, that is string processing. Find the given number, that is sorting. Okay, so in this lecture we discussed these topics, the important problem types. These important problem type for entire 5 units we going to discuss these problems using different algorithmic strategies like divide and conquer, brute force technique, and divide and greedy technique, dynamic programming, backtracking, branch and bone. These are different algorithmic strategies. Using these algorithmic strategies, we have different kind of problems in sorting, searching, string processing, all this problem. What are the examples we seen in this important problem types? All these examples we going to solve using these algorithmic strategies. Okay, so thank you for listening. Thank you so much.